Picture a tear in the fabric of space itself, a swirling vortex of impossible colors where the laws of physics bend and warp before your very eyes. This isn't science fiction, it's a wormhole, a cosmic shortcut through the universe, and for decades, it's captivated scientists, dreamers, and storytellers alike. But what if you could be the first to step through, to feel the pull of gravity unlike anything ever experienced, to witness stars and galaxies streak past in a blur of light and time? Today, we're embarking on a journey into one of the most thrilling mysteries of our cosmos, the universe's first wormhole travel. We'll explore 30 breathtaking theories that stretch from the edges of known physics to the wild frontiers of human imagination, blending cutting-edge science with visionary speculation. From the moment Einstein's equations hinted at the possibility of these spacetime tunnels, wormholes have represented more than just a mathematical curiosity. They symbolize humanity's deepest yearning to explore, to push beyond the known, and to touch the impossible. Whether they are seen as cosmic gateways, time machines, or even artifacts of a civilization far older than our own, each theory we'll uncover invites us to rethink our place in the universe. What would it take to traverse such a phenomenon? Could wormholes be natural formations, or might they be engineered by intelligence beyond our comprehension? And what secrets might they hold about the origin and destiny of the cosmos itself? This video is your ticket to a world where science and wonder collide. We'll journey through ideas that challenge everything we think we know, from quantum entanglement playing a role in stabilizing these cosmic passages, to the mind-bending concept that wormholes might not just connect space, but different dimensions or even alternate realities. Each theory is a piece of a grand puzzle, one that speaks to our innate curiosity and relentless drive to explore. So settle in, open your mind to the extraordinary, and join me as we dive into the exhilarating possibilities surrounding the universe's first wormhole travel. What we're about to explore might just change how you see the cosmos and our place within it forever. Our journey begins not with a journey forward, but a leap back, all the way back to the very inception of everything. The first theory we'll explore proposes that the universe's inaugural wormhole wasn't something engineered or discovered later on. It was a foundational feature of reality, a cosmic relic left over from the violent, explosive birth of the cosmos. This is the concept known as the Big Bang birth canal. Think of the universe in its first fleeting moments, a seething, impossibly dense and hot soup of energy where the very laws of physics were still taking shape. In this chaotic environment, the fabric of spacetime itself wasn't smooth. It was a turbulent quantum foam bubbling with tiny, spontaneous fluctuations. Under the immense gravitational pressures of the newborn universe, some physicists speculate that one of these random fluctuations could have been stretched and stabilized, pinching off a tunnel through the superheated geometry of primordial spacetime before it had even fully cooled. This wouldn't be a tunnel carved through an existing universe, but one woven into its very first threads. This idea transforms a wormhole from a mere passageway into something far more profound, a potential cosmic umbilical cord. If our universe is just one bubble in a vast multiverse, this primordial wormhole could have been a temporary connection to a sibling universe, a brief link through which energy or information might have flowed before it snapped shut under the strain of the universe's rapid expansion. It offers a tantalizing possibility that the very first act of travel through a wormhole might not have been conducted by any intelligence at all, but was a natural process of the cosmos birthing itself. The conditions for such an event are almost unimaginably extreme, relying on a delicate and unlikely dance between quantum mechanics and gravity, a partnership that remains one of the greatest unsolved mysteries in all of science. While this wormhole would almost certainly have collapsed instantly, its theoretical existence challenges our understanding of cosmic origins. suggesting that the potential for interconnection was built into the universe from its very first breath. But if the first wormhole was a monumental relic of the Big Bang, where does that leave the possibility of others? This brings us to a theory that operates on a scale so infinitesimally small it challenges our very perception of reality. Imagine the vacuum of space not as a true void, but as a seething, bubbling sea of energy. At the tiniest conceivable scales, at lengths 1,000,000 billion times smaller than an atom, the universe is constantly churning. This is the realm of quantum foam, a chaotic soup where spacetime itself is not smooth and continuous but froths with tiny, random fluctuations. Energy momentarily pops into existence and then vanishes, obeying the strange rules of quantum uncertainty that allow something to come from nothing, so long as it doesn't last too long. Within this frenzy, our second theory suggests that the fabric of reality is constantly pinching itself, forming and erasing countless microscopic wormholes every second. They would be unimaginably small, lasting for only a fraction of a second, but in that fleeting instant they could create a bridge between two distant points. To picture this, think of a pot of water just before it boils. Tiny bubbles form on the bottom, flickering in and out of existence. Now, imagine those bubbles are not in water, but in the very foundation of spacetime itself. Each bubble is a potential tunnel, a momentary shortcut. While these quantum wormholes would be far too small and unstable for any spacecraft to pass through, they hint at a profound possibility. What if information could traverse them? In the bizarre world of quantum physics, particles can be linked across vast distances through entanglement, instantly influencing each other. Some scientists have speculated that this spooky connection might actually be facilitated by these Planck-scale wormholes, providing a physical mechanism for what otherwise seems like magic. It suggests that the universe might be fundamentally threaded with these tiny, transient gateways, a hidden network of cosmic shortcuts woven into the fabric of everything. This idea pushes the boundaries of theoretical physics, proposing that wormholes aren't rare cosmic anomalies, but are born from the fundamental uncertainty that underpins all of reality. They are not built, they simply happen, a natural and constant process of the universe. While we lack the technology to ever detect such a fleeting phenomenon, its theoretical existence is a powerful reminder that the universe is far stranger and more interconnected than it appears. The potential for instant travel, even on a subatomic scale, is written into the chaotic, foamy nature of spacetime itself, suggesting that the blueprint for cosmic gateways has been there all along, hidden in the quantum noise. Now, let's venture into a theory that feels less like a quiet quantum whisper and more like a cosmic thunderclap. Imagine the universe in its infancy, less than a second old. It's a seething, super-dense arena not of planets and stars, but of unimaginably ancient and dense objects known as primordial black holes. These aren't the black holes formed from collapsing stars. They are thought to be left over from the Big Bang itself, raw knots of gravity that could range in size from a mountain to a planet. In this chaotic early cosmos, two such behemoths could have been drawn together in a gravitational dance, spiraling closer and closer until they finally merged. But our third theory proposes that under the perfect, extreme conditions of that collision, something far more spectacular than a larger black hole might have been forged. The incredible energies and the warping of spacetime could have stitched their event horizons together, not just merging their singularities, but twisting the fabric of reality to form a tunnel, a stable wormhole. The mathematics behind this idea is as profound as it is complex. When two black holes collide in modern simulations, we see gravitational waves ripple out across the universe. But in the unique environment of the early universe, where the density of matter and energy was far greater, physicists speculate that the merging of their event horizons, the points of no return, could have taken on a different geometry. Instead of simply forming a larger spherical horizon, the intense forces could have stretched and connected them, creating a throat-like structure bridging the 2 points. This is where the most speculative yet crucial ingredient comes in: exotic matter. To prevent this newborn wormhole from immediately pinching off and collapsing into a new singularity, it would need a form of matter with negative energy density, something that exerts negative pressure or repulsive gravity to prop the tunnel open. In the frenzy of a primordial black hole merger, some theories suggest that the quantum fields around the collision could have briefly generated just enough of this exotic material to stabilize the passage, if only for a little while. This concept transforms a wormhole from a passive feature into a dynamic event, a cosmic structure born from the most violent marriage imaginable. It suggests the first natural gateway wasn't a gentle quantum fluctuation or a relic of creation, but the explosive aftermath of a crash between titans. If such an event occurred, this wormhole could have served as the universe's first true shortcut, a tunnel instantly connecting 2 regions of space that were otherwise impossibly far apart in the rapidly expanding cosmos. Matter or energy falling into one black hole could have, in theory, been ejected from the other, creating a natural transportation system woven into the architecture of the young universe. While the stability of such a structure remains a monumental if in physics, the theory offers a compelling narrative that the key to traversing the cosmos might have been forged in the fire of its most extreme and fundamental interactions. But what if the universe's first stable wormhole wasn't forged in a violent collision, but woven into existence by something far more bizarre and fundamental? This brings us to our 4th theory, which involves cosmic strings. To understand these, we need to shift our perspective of the universe once again. Picture the cosmos not long after the Big Bang as it expanded and cooled. During this phase transition, much like water freezing into ice, physicists theorize that the very fabric of spacetime might have crystallized imperfectly. These imperfections could have taken the form of unimaginably thin, incredibly dense filaments of pure energy cosmic strings. Think of them as one-dimensional cracks in reality, thinner than a proton but with the mass of a mountain range packed into every inch, and under such immense tension that a single loop would vibrate with the power of a billion suns. Now imagine 2 of these cosmic strings, these ultra-dense scars in spacetime, gliding across the young universe. According to this theory, if 2 such strings were to cross or slide past one another, the gravitational chaos would be off the charts. Their immense mass and the unique way they warp spacetime around them could cause a phenomenal distortion. At the precise point of intersection, the combined gravitational pull could be so extreme that it literally punches a hole through the fabric of the cosmos, not creating a black hole but a permanent tunnel, a wormhole. This wouldn't be a fleeting quantum event or a structure on the verge of collapse. The unique properties of the cosmic strings could theoretically provide the exotic matter or the specific warping needed to hold the throat of the wormhole open, making it a stable and potentially traversable gateway. The implications of this are staggering. If such intersections occurred, the first wormholes could have been incredibly durable, perhaps even surviving to the present day. They wouldn't just be curiosities, they could have played an active role in shaping the universe we see. As the cosmos expanded, these ancient tunnels might have acted as gravitational anchors, influencing how matter clumped together to form the very first galaxies and the vast cosmic web that connects them. A wormhole created by cosmic strings would be a true fixture of the universe, a permanent superhighway etched into the architecture of reality during its earliest moments. While the existence of cosmic strings themselves remains theoretical, this idea offers a compelling and elegant mechanism for how the cosmos might have built its own stable network of shortcuts, setting the stage for travel on a truly cosmic scale. Now we shift our perspective from cosmic strings to an idea that is both more fundamental and far more unsettling. Our 5th theory suggests that the first wormhole might not have been built by the universe but born from its potential destruction. This revolves around a concept in quantum field theory known as the vacuum metastability event. To understand this, we must first re-examine what we mean by nothing. The vacuum of space isn't truly empty. It's filled with a background energy field called the Higgs field, which gives particles their mass. For our universe to function as it does, this field exists in a state known as a false vacuum. It's stable for now, but it might not be the lowest possible energy state it could be in. Think of it like a ball resting in a small valley on the side of a much larger mountain. It seems stable, but if it were ever knocked into the deeper valley below, it would release a colossal amount of energy as it fell. A vacuum decay event would be that nudge. If a tiny bubble of this lower energy, true vacuum, were to spontaneously form anywhere in the universe, perhaps due to a quantum fluctuation, it would immediately begin expanding at the speed of light. The boundary of this bubble would be a wall of unimaginable energy, rewriting the fundamental laws of physics in its wake. Atoms as we know them would cease to exist, and the constants of nature would change. It would be the ultimate cosmic catastrophe, an irreversible end to our universe as we know it. But within this wave of annihilation, our theory proposes could lie the seeds of creation. As this wall of true vacuum expands, the violent phase transition at its boundary could create topological defects in the fabric of spacetime. Just as freezing water can trap air bubbles, the freezing of the universe into a new state could trap structures like cosmic strings or, more importantly for us, wormholes. These wouldn't be gentle passages but violent scars, tears in reality formed in the chaotic upheaval between two completely different sets of physical laws. The immense energies involved could provide the exotic matter or the severe warping needed to force a tunnel open and potentially stabilize it. In this terrifying scenario, the first traversable wormhole would be a ghastly byproduct of the universe's death, a single beautiful and functional structure emerging from the ashes of everything that was. It presents a profound and paradoxical idea that the ultimate gateway for travel and exploration might only be forged in the process of total cosmic annihilation. While the probability of such an event occurring is incredibly low, its theoretical possibility reminds us that the universe's most magnificent structures could be born from its most violent processes. This brings us to a theory that shifts our focus from the universe's violent beginnings to its mysterious future, proposing that the first wormholes weren't forged in creation or destruction, but were a necessary byproduct of the cosmos's accelerating expansion. Imagine dark energy not just as a mysterious force pushing galaxies apart, but as an active sculptor of spacetime itself. We know the universe's expansion is speeding up, driven by this enigmatic dark energy that seems to be inherent to the vacuum of space itself. Some of its proposed properties are truly bizarre, including negative pressure and a repulsive gravitational effect. The very same qualities theorists say are needed to prop open a wormhole and prevent its collapse. This sixth theory, the dark energy conduit theory, suggests that in the extreme conditions of the early universe, this repulsive energy might have spontaneously focused itself, punching stable tunnels through the fabric of reality as a form of cosmic pressure release valve. Think of it like a pot of water boiling over. As the universe expanded and dark energy's influence grew, the mounting pressure might have needed an outlet. Regions of intensely negative energy density could have bubbled up, and in doing so, they warped spacetime so severely that they connected two distant points with a shortcut. These wouldn't be wormholes formed by mass, like those from black holes, but wormholes formed by the absence of it, by the repulsive push of a force we still don't fully understand. In this view, the first traversable wormhole wasn't a tunnel through space, but a tunnel of space, a conduit created by the very mechanism that is relentlessly stretching the cosmos apart. It presents a beautiful symmetry. The force responsible for creating vast, unbridgeable distances between galaxies might also have provided the very means to cross them instantly. The implications of this are profound. If dark energy can naturally form these structures, then the cosmos could be threaded with an ancient network of wormholes, a hidden subway system laid down when the universe was young. They wouldn't be anomalies, they'd be fundamental features of an accelerating universe, as natural as the expansion itself. This theory elegantly ties together two of cosmology's greatest mysteries, dark energy and wormholes, suggesting that the answer to one might be found in the behavior of the other. It transforms our understanding of dark energy from a passive, background force into an active and potentially creative agent, one that may have woven connectivity into the universe even as it was destined to tear it apart. But to truly push our understanding of the first wormhole to the absolute limit, we must venture even further back than the Big Bang's afterglow, before the formation of any particles or forces as we know them. We must journey to the very first moment of time itself, to a period so brief and so extreme that our current laws of physics simply break down. This is the Planck era, the universe's first 10 to the power of -43 seconds. At this scale, the cosmos was smaller than a single atom, a seething, chaotic realm where gravity was not a smooth force but a quantum one, and spacetime was not a stage but a turbulent, frothing actor. In this primordial quantum foam, the very concepts of here and there lost all meaning. Reality was a probabilistic storm, constantly fluctuating. It is within this unimaginable chaos that our seventh theory proposes the first wormholes were not just formed, but were an intrinsic part of the fabric of existence. These wouldn't be tunnels in the classical sense. They would be more like quantum connections, instantaneous bridges between different potential states of the infant universe. Before the rapid expansion of cosmic inflation smoothed everything out, the universe was a landscape of extreme probabilities. A wormhole in this context could have served as a conduit between two different quantum configurations, a short circuit in reality that allowed information or influence to flow between what were essentially different potential versions of the cosmos. This idea is deeply tied to the quest for a theory of quantum gravity, a framework that would unite the large-scale world of general relativity with the probabilistic world of quantum mechanics. In some approaches, like loop quantum gravity, spacetime itself is thought to be composed of a network of discrete loops. Wormholes could be visualized as extra connections in this network, tiny threads weaving different parts of the cosmic tapestry together before it was stretched to a macroscopic scale by inflation. The fate of these Planck-era wormholes is perhaps the most fascinating part. When the universe underwent its period of hyper-fast inflation, expanding by an astronomical factor in a tiny fraction of a second, any of these microscopic quantum tunnels that existed would have been stretched along with everything else. A wormhole that was once a billionth of a billionth the size of a proton could have been inflated to a macroscopic scale, potentially large enough to one day accommodate a starship. This provides a breathtakingly elegant origin story. The cosmic gateways we dream of today might be ancient relics, quantum fossils magnified to cosmic proportions by the universe's own explosive growth. They would be the oldest structures in existence, predating the first particles, the first forces, and even the concept of time as we experience it. This theory doesn't just suggest that wormholes are possible. It implies they are a fundamental and necessary feature of a quantum spacetime, and that our universe may be filled with these magnified quantum threads, connecting points that were intimate neighbors in the first fleeting moment of everything. This brings us to a theory that directly builds on the quantum origins we just explored, proposing a specific and powerful mechanism for how those microscopic bridges could have become the cosmic superhighways of our dreams. We're talking about the inflationary universe bridge. To grasp this, we need to revisit one of cosmology's most pivotal events, cosmic inflation. Picture the universe in its first fleeting moments, a singular point of unimaginable energy. Then, in a fraction of a second, it underwent an exponential growth spurt, expanding by a factor of trillions upon trillions, smoothing out the cosmos and planting the seeds for all future galaxies. This inflationary period didn't just stretch space, it stretched everything within it, including the quantum foam and any primordial wormholes that flickered into existence during the Planck era. Think of it like a cosmic balloon. Draw two dots right next to each other on a deflated balloon. They are neighbors. Now inflate the balloon to an enormous size. Those two dots are now vastly far apart, but imagine if at the moment you drew them, you also connected them with a tiny thread. As the balloon inflates, that thread isn't just stretched, it's elongated. This is precisely what the inflationary bridge theory suggests. A wormhole, a quantum thread connecting 2 points in the primordial foam, would have been stretched along with the fabric of spacetime itself during inflation. The incredible forces at work wouldn't have necessarily broken this connection. Instead, they could have pulled it into a stable, macroscopic tunnel. A structure that began smaller than a subatomic particle could have been inflated to a size spanning light years, or even connecting entire galactic superclusters. The genius of this idea is that it solves one of the biggest problems in cosmology, the horizon problem. We observe that the universe has a uniform temperature and structure in all directions, yet according to standard models without inflation, these regions could never have been in contact to achieve this equilibrium. Inflation solves this by saying everything was once close together before rapidly flying apart, but the inflationary bridge theory adds an elegant twist. It suggests that even after inflation drove regions apart, they might have remained physically connected by these stretched wormholes, so areas of space that appear to be forever separated by unimaginable distances beyond each other's observable horizons could in fact be linked by an ancient, invisible shortcut, a relic from the universe's first moment of hypergrowth. This transforms our understanding of the cosmos. It implies that the large-scale structure of the universe might not be a simple expanse of empty space between islands of galaxies. Instead, it could be laced with a hidden network of tunnels, a cosmic subway system laid down during the universe's infancy. These bridges wouldn't be anomalies, they'd be fundamental features of an inflationary cosmology, as natural as the cosmic microwave background radiation. The first wormhole travel might not involve finding a new phenomenon, but simply discovering and navigating this pre-existing infrastructure that has been woven into the universe's architecture since the beginning of time. It's a theory that elegantly connects the universe's smallest-scale quantum behavior with its largest-scale structure, suggesting that the key to crossing the cosmos was built right into the mechanism of its creation. Now we venture into one of the most radical and mind-bending theories of all, a concept that turns our entire understanding of cosmic origins inside out. This is the white hole revelation theory, and it proposes a staggering idea. Our entire universe, everything we know and see, might not be the result of a spontaneous Big Bang, but the destination of the universe's very first wormhole journey. To understand this, we first need to grasp what a white hole is. In the equations of general relativity, if a black hole is a one-way door into a gravitational prison from which nothing can escape, a white hole is its theoretical opposite, a one-way exit. It's a region of spacetime that can eject matter and energy out into the cosmos, but nothing can ever fall back into it. It's like a cosmic fountain that only pours out, never draining. This theory takes that concept and applies it to the ultimate beginning. It suggests that the Big Bang itself was not a mysterious explosion from a singularity, but the white hole in point of a gargantuan wormhole originating from another universe entirely. In this breathtaking scenario, our entire cosmos is the result of matter, energy, and the very laws of physics being ejected from this white hole portal. We are not the first chapter of a story, we are the second. Some other, older universe, a parent cosmos experienced an event that forged a stable, traversable wormhole. One end remained a black hole in that parent universe, drawing in material, while the other end erupted into a new region of reality as a white hole, giving birth to what we now call our universe. This transforms the act of first travel from a deliberate journey to a cosmic migration. The first travelers through this wormhole wouldn't have been astronauts or a probe. They could have been the fundamental building blocks of reality itself, spacetime, quantum fields, and energy transiting from one cosmic realm to create an entirely new one. Our universe's initial conditions, its precise laws and constants that seem so perfectly tuned for life, might not be random. They could be the inherited physics from that parent universe, filtered and perhaps even altered during the traversal through the wormhole's throat. This idea offers a compelling and elegant solution to the mystery of the Big Bang's origin, suggesting it was not the absolute beginning but a profound transition, a bridge between cosmic generations. The implications are truly universe-shattering. It means our cosmos is fundamentally connected to another, a branch on an infinite fractal tree of universes. The cosmic microwave background radiation, the afterglow of the Big Bang we detect from every direction, might not be the echo of a creation event, but the lingering energy signature of that white hole eruption. This theory doesn't just provide a mechanism for the first wormhole. It redefines our entire existence as potentially being the product of the first and most monumental journey ever taken. We are all, in a very real sense, the descendants of that initial cosmic passage, living in the outcome of the universe's first wormhole travel experience. Yet what if the very fabric of our reality is far more expansive than the three dimensions of space and one of time that we perceive? This brings us to a theory that requires us to fundamentally reimagine the architecture of the cosmos. Theory 10, the extra dimension shortcut, proposes that wormholes are not just tunnels through our universe, but gateways that utilize hidden, higher dimensions we cannot directly see. This idea is rooted in one of the most ambitious frameworks in modern physics, string theory. To make their equations work, string theorists propose that the universe isn't four-dimensional but exists in 10, 11, or even 26 dimensions. The reason we don't perceive these extra dimensions is that they are compactified or curled up into an unimaginably tiny scale, smaller than a subatomic particle. Now imagine our four-dimensional universe not as an isolated stage, but as a membrane or brain, floating within a much higher dimensional realm called the bulk. This is the core of brain cosmology. In this view, all the matter and forces we know, everything from atoms to light, are stuck to our brain like ink on a page. But gravity is different. It's so weak compared to the other forces that one explanation is it can leak off our brain and propagate through the higher dimensional bulk. This leakage could be the key to the first wormholes. If gravity can seep into the bulk, then the fabric of spacetime on our brain might have folds or wrinkles that connect to it. A wormhole in this scenario wouldn't just bend space within our dimensions. It would be a bridge that arcs through the bulk, creating a shortcut that bypasses the vast distances of our own brain entirely. Think of it like this: you are an ant living on a single, vast sheet of paper. To get from one point to another on that flat sheet, you have to walk the entire distance. But if that paper is crinkled, and you could somehow tunnel through the third dimension, popping up through the air and landing at your destination, your journey would be instantaneous. For us, the wormhole is that tunnel through the higher dimensional air. The formation of the first such shortcut could have been a natural process. In the high-energy environment of the early universe, quantum fluctuations or collisions between brains could have punched a hole through our dimensional membrane, creating a stable connection through the bulk to another point on our brain, or even to an entirely different brain universe. The energy required to open such a passage might be far less when you can utilize the geometry of higher dimensions, making the spontaneous creation of a traversable wormhole not just possible, but perhaps even likely. This theory elegantly solves the problem of the wormhole's immense energy requirements. Instead of needing mythical exotic matter to prop open a tunnel in 4 dimensions, the shortcut through the bulk might be naturally stabilized by the geometry of the higher dimensions themselves. It transforms the wormhole from a fantastical anomaly in our universe into a fundamental feature of a multidimensional cosmos. If this is true, then the first act of wormhole travel wouldn't have been a journey through space, but a journey out of it, a dip into a hidden dimensional realm that has been there all along, offering a cosmic network of shortcuts that we are only now beginning to imagine. But to truly bend our minds, we must now consider a form of matter that defies the most fundamental laws of physics as we know them. Theory 11 proposes a mechanism so strange it sounds like pure magic, the time crystal mechanism. To grasp this, we first need to understand what a time crystal is. Imagine a snowflake, a structure with atoms arranged in a repeating, periodic pattern in space. Now try to imagine a structure that does the same thing but in time. A time crystal is an object that is in perpetual motion, not because it's being pushed by an external force, but because its ground state, its lowest energy state, is one of oscillation. It's like a clock that ticks forever without any batteries, a system that breaks time translation symmetry by having a preferred moment in time that repeats indefinitely, all while consuming zero energy. The existence of such objects was once thought to be impossible, as they seemed to flirt with the idea of a perpetual motion machine. Yet, in recent years, scientists have successfully created small-scale time crystals in controlled laboratory settings, proving that this bizarre phase of matter is very real. Now, let's project this concept back to the universe's first moments. In the extreme energies following the Big Bang, before the cosmos had cooled and settled, it's conceivable that vast, naturally occurring time crystals could have formed. These wouldn't be tiny lab curiosities, but cosmic-scale structures, their atoms or fundamental fields locked into an eternal, rhythmic dance across the fabric of spacetime itself. This is where the connection to wormholes becomes truly fascinating. General relativity tells us that massive, rotating objects drag spacetime around with them, an effect known as frame dragging. A time crystal, by its very nature, is a structure with an intrinsic, perfectly periodic rotation or oscillation built into its core. A cosmic-scale time crystal would be the ultimate frame-dragging engine, rhythmically twisting the fabric of reality around it with unimaginable power. The theory suggests that the precise, stable, and perpetual oscillations of these early universe time crystals could have generated a resonance in spacetime. This rhythmic warping might have been so powerful and so perfectly tuned that it did not just create a gravitational well, but stitched a tunnel through it, a wormhole stabilized not by exotic matter, but by the unwavering, eternal beat of the crystal itself. The most profound implication here is that such a wormhole wouldn't just be a bridge through space. Because the crystal's mechanism is fundamentally temporal, the tunnel it creates could intrinsically link 2 different points in time as well. The oscillation provides a natural, stable structure for time to fold upon itself, creating a passageway where entering at one moment could mean exiting at another, entirely different moment in history. The first wormhole forged by a time crystal wouldn't be a mere shortcut. It would be the universe's first natural time machine, a gateway where the concepts of where and when become fluid and interchangeable. This presents a staggering vision of the cosmos where the most ancient structures are not silent monuments, but are actively, perpetually humming, their rhythm-maintaining tunnels that connect not just distant stars but different epochs of cosmic history. Now we turn to a concept that bridges the bizarre quantum world with the vast cosmic scale, connecting 2 of physics' greatest mysteries into a single, elegant theory. This is the quantum entanglement gateway, and it begins with what Einstein himself famously called spooky action at a distance. Quantum entanglement is that strange phenomenon where 2 particles become linked, their fates intertwined. No matter how far apart they're separated across a lab or across the galaxy, measuring the state of one particle instantly determines the state of the other, as if they're communicating faster than the speed of light. This seems to violate the fundamental cosmic speed limit set by relativity, creating a paradox that has puzzled scientists for nearly a century. But what if this spooky connection isn't a mysterious, invisible signal, but a physical bridge? This theory proposes that entanglement is not action at a distance at all. It is action through a tunnel. The idea is that when two particles become entangled, a microscopic, Planck-scale wormhole forms between them, linking their positions through a shortcut in spacetime. This wormhole is far too small for any matter or light to pass through, but it provides a physical conduit through which quantum information can be instantly shared. In this view, the particles aren't communicating. They are simply two ends of the same cosmic string, connected by a hidden umbilical cord woven into the fabric of reality itself. This provides a stunningly elegant solution to the paradox, reconciling quantum mechanics with general relativity by suggesting that entanglement and wormholes are not just similar concepts, they are two different descriptions of the exact same phenomenon. This leads us to the truly cosmic part of the theory. If a microscopic wormhole can connect two particles, could a macroscopic one connect two stars? The proposal is that the universe's first traversable wormhole formed when this process of entanglement was scaled up to a monumental degree. In the incredibly dense early universe, particles weren't just pairing up. Entire regions of space-time, vast clouds of primordial gas, or even the first proto-galaxies could have become quantumly entangled with one another. As the universe expanded, these regions were pulled apart by inflation, but their quantum connection remained, a spooky link across the growing void. The theory suggests that under the right conditions, this persistent, large-scale entanglement could have acted as a template, a sort of cosmic blueprint. The fabric of spacetime itself, still malleable in the young cosmos, might have responded to this profound connection by physically manifesting it. The quantum link could have guided the formation of a real, stable wormhole, effectively stitching a macroscopic tunnel between those two now distant points. This process would transform an abstract quantum connection into a concrete gravitational one. The first travelers through such a gateway wouldn't be plunging into a random anomaly. They'd be walking a path that was predestined by the universe's own quantum mechanical history. It suggests that the cosmic web of galaxies we see today, with its vast filaments and voids, might be underpinned by an even deeper web of quantum connections, some of which have physically realized themselves as wormholes. The universe, in its first act of large-scale travel, might not have created a new pathway but simply revealed a hidden one that was there all along, written into the quantum relationships forged at the dawn of time. This theory beautifully unites the smallest and largest scales of physics, proposing that the key to crossing the universe was encoded in the spooky bonds between the first particles to emerge from the Big Bang. Yet what if the universe's first great shortcut wasn't forged by the impersonal forces of physics, but by something far more profound, a thought? This brings us to a theory that exists at the very farthest frontier of speculation, a place where science, philosophy, and metaphysics converge. Theory 13, the consciousness-created wormhole, dares to suggest that the first traversable gateway was not a product of gravity, quantum fields, or higher dimensions, but a physical manifestation of mind itself on a cosmic scale. This idea stems from a radical interpretation of the role of observation in quantum mechanics, where the act of measuring a particle's state seems to determine its reality. Some interpretations propose that consciousness is not a passive byproduct of the universe, but an active participant in its very construction. If that is true, then what might a truly cosmic consciousness be capable of? Imagine a universal mind, not as a deity in a traditional sense, but as an intrinsic property of the cosmos, a fundamental field of awareness as real as the gravitational or electromagnetic fields. This consciousness wouldn't be located in a brain. It would be woven into the fabric of space-time, a network of self-aware information present at the universe's birth. In this view, the formation of the first wormhole could have been an act of cosmic will, a deliberate folding of reality to facilitate a flow of information or experience. Think of it not as engineering, but as a form of focused intention on a scale we can scarcely comprehend. The immense energy required to warp space-time and hold a tunnel open wouldn't come from exotic matter, but from the directed power of this universal consciousness itself, translating pure thought into physical geometry. To find a remote parallel in our own world, consider the immense focus and collective intention required for humanity's greatest achievements, building a cathedral or launching a probe to another planet. These are physical structures born from a shared idea. This theory scales that concept up to the ultimate degree, proposing that the universe, in its desire to know itself or to connect its disparate parts, might have manifested a physical bridge. The wormhole becomes less a tunnel and more a synapse, a neural connection in the mind of the cosmos, allowing for the instantaneous transfer of experience and information from one point to another. It suggests that the first act of travel was not a journey of matter, but a journey of mind, a moment of cosmic self-awareness made physically real. The implications of this idea are as vast as they are untestable by current science. It posits a universe that is not merely alive with life, but is itself a form of life, a conscious entity whose physical structures can be influenced by its own awareness. A wormhole created in this way would be more than a shortcut. It would be a symbol, a physical testament to the idea that information and thought are not just contained within the universe, but are fundamental forces that can shape it. While firmly in the realm of speculation, this theory challenges our most basic assumptions about the relationship between mind and matter, inviting us to consider that the greatest mysteries of the cosmos might not be found in the behavior of particles, but in the nature of consciousness itself. Yet what if the first stable wormhole wasn't forged in the gentle cradle of quantum foam or the violent chaos of the Big Bang, but in the searing, focused beam of the universe's most powerful natural accelerators? This brings us to a theory that finds its origins not in the beginning of time, but in the spectacular deaths of stars. Theory 14, the natural particle accelerator, proposes that the incredible energies needed to warp spacetime into a tunnel were generated by some of the most extreme objects in the cosmos, primordial black holes and neutron stars. These celestial powerhouses act as nature's own version of the Large Hadron Collider, but on a scale that makes our greatest machines seem utterly puny. They can accelerate particles to energies we can scarcely replicate, hurling them across the universe at a fraction of the speed of light. To understand the sheer power we're talking about, consider a neutron star. When a massive star explodes in a supernova, its core can collapse into a city-sized object so dense that a single teaspoon of its material would weigh billions of tons. Many of these neutron stars spin hundreds of times per second, generating immense magnetic fields trillions of times stronger than Earth's. Charged particles caught in these fields are whipped around like a cosmic slingshot, gaining unimaginable energy before being ejected as intense beams of radiation. Similarly, the chaotic, violent environment around a feeding primordial black hole, a relic from the universe's first second, would be a maelstrom of accelerated matter and radiation. In these frenzied zones, particles aren't just moving fast, they are being smashed together with forces that recreate the conditions of the early universe. The theory suggests that within these natural accelerators, a perfect storm of energy could have occurred. Imagine two ultra-high-energy cosmic rays, perhaps protons accelerated to near light speed by a spinning neutron star, are flung across the void. By a 1 in a trillion chance, they collide head-on not in empty space, but within the intensely warped gravitational field right at the event horizon of a primordial black hole. The energy released in such a collision would be astronomical, but it's the unique location that makes it special. General relativity tells us that gravity is the curvature of spacetime. An immense energy release within an area that is already severely curved could, in theory, punch right through the fabric of reality. The concentrated blast could act like a cosmic needle, stitching a thread between the point of impact and another distant region of severely warped spacetime, effectively sewing a wormhole into existence. This wouldn't be a gentle process, it would be a violent, spontaneous eruption of geometry. The energy from the particle collision would provide the necessary kick, while the pre-existing extreme gravity of the black hole or neutron star would provide the framework, the divot in spacetime that makes such a rupture possible. For a fleeting instant, the energy density at the point of impact could be so extreme that it generates the negative energy density, the exotic matter, needed to hold the wormhole's throat open long enough for it to become a stable feature. It's a theory that turns the cosmos's most destructive events into potential creators, suggesting that the very processes that tear stars apart might also be responsible for weaving the threads that could one day connect them. The first wormhole might not have been a quiet quantum whisper or a grand cosmological event, but the spectacular, random side effect of a cosmic particle cannon firing at point-blank range into the heart of gravity itself. This brings us to a theory that hinges on a ghost, a particle that has never been seen, yet whose shadow has loomed large over physics for over a century. This is the idea of magnetic monopole catalysis, a process that might have used one of the universe's greatest theoretical missing pieces to forge its first great shortcuts. To understand this, we first need to grasp what a magnetic monopole is. Every magnet we've ever encountered, from a simple refrigerator magnet to the Earth itself, has two poles, a north and a south. You can break a magnet in half, but you'll never get an isolated north or an isolated south. You'll just get two smaller magnets, each with its own pair of poles. This is a fundamental rule of our electromagnetic universe, but many of our most ambitious theories, like grand unified theories that seek to merge the fundamental forces, predict that this wasn't always the case. In the unimaginable heat of the universe's first fractions of a second, the electromagnetic and nuclear forces were fused into a single, unified force. In that environment, theory suggests that particles with a single magnetic charge, true north or true south poles existing completely on their own, could have formed. These are magnetic monopoles. They would be incredibly massive, perhaps as heavy as a bacterium yet smaller than a proton, making them phenomenally dense. More importantly, their magnetic charge would be immense, billions of times stronger than anything we see in today's universe. As the cosmos expanded and cooled, the forces split apart in a phase transition called symmetry breaking, and it's thought that these primordial monopoles, these cosmic fossils from a more symmetric age, would have been frozen out into the newborn cosmos. Now, imagine one of these monstrous particles drifting through the turbulent plasma of the early universe. Its immense gravity would warp space-time around it like a bowling ball on a trampoline. But its gargantuan magnetic charge would do something even more exotic. According to some theories, the magnetic field around a monopole wouldn't be a simple dipole field like a bar magnet. It would be a radial field emanating outward in all directions like the gravitational field of a planet. This radial field could theoretically interact with the quantum vacuum in a unique way, polarizing it and creating a region of negative energy density around the monopole. The very same repulsive gravity or exotic matter needed to prop open a wormhole and prevent its collapse. The catalysis theory proposes that when two of these monopoles with opposite magnetic charges were drawn together in the early universe, their approach wouldn't just be a simple collision. Their powerful, opposing magnetic fields would cause them to spiral around each other in a violent, energetic dance. As they whipped around at fantastic speeds, their combined gravitational and electromagnetic influence could have become so extreme that it twisted the local fabric of spacetime into a knot. The negative energy density generated by their fields could have provided the stabilizing force, allowing this knot to resolve not into a new singularity, but into a stable tunnel, a wormhole bridging the space between their original positions. In this scenario, the monopoles wouldn't be destroyed. They could become anchored at either end of the tunnel, their immense properties acting as natural anchors to keep the throat of the wormhole permanently open. The beauty of this idea is that it provides a concrete, albeit hypothetical, mechanism for creating a stable, traversable wormhole without needing to invent new physics. It uses predicted properties of particles that many physicists believe must exist. If this occurred, the first wormholes could have been incredibly durable structures, perhaps even surviving to the present day. We might one day detect a wormhole not by looking for gravitational anomalies alone, but by searching for the unique, powerful signature of a magnetic monopole at its mouth. This theory turns the hunt for one of physics' holy grails into a potential roadmap for discovering the ultimate cosmic shortcut, suggesting that the key to unlocking the stars might be found by first finding the missing piece of every magnet we've ever known. Now let's explore a theory that takes us back to the very moment the universe began to settle into its familiar form, a process where the very nature of gravity itself may have undergone a dramatic shift, literally freezing cosmic shortcuts into existence. This is the quantum gravity phase transition theory. To grasp this, we need to envision the early universe not just as hot and dense, but as a place where the fundamental forces were utterly unrecognizable. In the first fleeting instance after the Big Bang, the four forces we know today, gravity, electromagnetism, and the strong and weak nuclear forces, were fused into a single, unified superforce. As the cosmos expanded and cooled, it went through a series of phase transitions, much like steam condensing into water or water freezing into ice. Each time, one of the forces broke away and took on its own unique identity. The most profound of these transitions would have been the one where gravity peeled away from the others. At this critical moment, the quantum nature of gravity, which is so elusive to us now, would have been dominant. As this phase transition occurred, the fabric of spacetime itself was crystallizing into its stable, four-dimensional form. And just as freezing water can trap air bubbles or form cracks and fissures in the ice, this cosmological freezing could have trapped defects in the very structure of reality. We've already discussed how this process might create one-dimensional cracks known as cosmic strings. But the quantum gravity phase transition theory proposes something far more complex, the formation of wormholes as topological defects. A topological defect is a stable, persistent imperfection that gets locked into a material during a phase change. A simple analogy is found in polycrystalline materials. When metal cools, different regions or crystals form with their atoms aligned in specific directions. Where these differently aligned regions meet, a grain boundary forms, a stable defect in the otherwise orderly atomic lattice. Now scale that idea up to the entire universe. As the quantum foam of gravity settled into the smooth, classical spacetime we know, different regions might have crystallized with slightly different geometries. Where these differing regions of spacetime met, the theory suggests, the interaction wouldn't create a simple seam. Instead, the mismatch could have resolved itself by forming a tunnel, a wormhole connecting the two regions. This wormhole wouldn't be an object in spacetime. It would be a flaw of spacetime itself, a permanent feature woven into the cosmic fabric during its moment of formation. The geometry of such a structure is mind-bending. Unlike a cosmic string, which is a one-dimensional line defect, a wormhole formed this way would be a more complex, three-dimensional topological feature, a handle or a bridge permanently attached to the fabric of the universe. Its stability wouldn't rely on exotic matter. It would be guaranteed by topology, the mathematical study of shapes and their properties. Just as a donut cannot be smoothly transformed into a coffee cup without poking a hole in it, they are topologically distinct. This wormhole would be a fundamental part of the universe's shape, as permanent and unchangeable as its very dimensions. The first wormholes, in this view, were not accidents or anomalies. They were an inevitable byproduct of the universe cooling into its current state, cosmic fossils left over from the moment gravity became the force we recognize today. This offers a profoundly elegant origin story, suggesting that the potential for instantaneous travel was not something added to the universe later, but was literally baked into its geometry at the moment of its creation. Now we venture into one of the most profound and abstract theories of all, a concept that suggests the universe we perceive might be a projection, a cosmic illusion, and that wormholes are the threads connecting the illusion to its source. This is the holographic principle manifestation. To grasp this, we need to rethink reality at its most fundamental level. The holographic principle is a revolutionary idea in theoretical physics proposing that all the information describing a three-dimensional volume of space, every star, every planet, every person, can be entirely encoded on its two-dimensional boundary, much like a three-dimensional image is encoded on a flat, two-dimensional piece of holographic film. In this view, our lived experience of a 3D universe is a projection, a hologram emanating from a vast, complex network of information stored on the cosmological horizon. Think of it like watching a movie on a screen. The images appear to have depth and dimension, with characters moving toward you and away from you, but all that information is actually contained in the flat, two-dimensional pixels of the screen itself. The holographic principle suggests our universe operates in a similar way. The boundary of our observable universe, the farthest point from which light has had time to reach us since the Big Bang, acts as that cosmic screen. Everything within the volume is a projection from the information encoded on that spherical surface. This isn't just a poetic metaphor. It emerges from the physics of black holes, where the maximum amount of information a region can contain is proportional not to its volume, but to the area of its surface. So, where does the first wormhole fit into this astonishing picture? The theory proposes that a wormhole is not a tunnel through space, but a direct connection between 2 points on this vast informational boundary. Imagine 2 distant points on the universe's horizon, each encoding a different part of the cosmic hologram. Under certain conditions, the information at these 2 separate locations could become entangled or correlated in a specific way. This profound link on the 2D boundary wouldn't just create an abstract connection. It would manifest within the 3D projection as a physical structure, a wormhole bridging the 2 corresponding points in the perceived volume of space. The wormhole becomes a physical manifestation of an informational shortcut. This leads to an even more incredible possibility for its origin. The first wormhole might not have been a random fluctuation, but the result of the universe's own initial information processing. As the cosmos cooled from the Big Bang and the holographic nature of reality began to take shape, the information on the boundary was being written and organized. This theory suggests that the first stable wormhole could have emerged as a kind of cosmic circuit, a feedback loop created to efficiently transfer or process information between different sectors of the nascent cosmic code. It would be a structure born not from gravity or quantum fields alone, but from the fundamental need for the universe to manage the immense data that defines its own existence. The act of first travel through such a gateway would therefore be a journey that somehow touches the source code of reality itself, moving through a tunnel that is, at its heart, a stream of pure information made geometrically real. This idea transforms our quest from finding a physical anomaly to deciphering the deepest informational patterns of the cosmos, suggesting that the ultimate map of the universe's wormholes is written not in stars but in bits. Yet for all these theories of cosmic scale phenomena, what if the architect of the first wormhole was not a force of immense energy but one of profound absence? We now turn our attention to a substance that is defined more by what it isn't than what it is: dark matter. This mysterious, invisible substance makes up over 85% of the matter in the universe, yet it neither emits nor reflects light, revealing itself only through its gravitational pull on the galaxies and stars we can see. Theory 18, dark matter sculpting, proposes that this enigmatic material did more than just provide the gravitational scaffolding for galaxies. It may have actively woven the fabric of the first cosmic shortcuts. The key lies in dark matter's unique distribution and its profound gravitational influence on the geometry of spacetime itself. Unlike normal matter, which can clump together, collide, and radiate energy away, dark matter is thought to be cold and collisionless. This means that after the Big Bang, it was able to collapse into vast, intricate structures long before normal matter could. Picture the early universe as a cosmic web in the making, with dark matter forming an invisible skeleton of dense filaments and immense halos, while the familiar atoms of gas and dust simply flowed into the gravitational wells this dark scaffolding created. Within these dense knots and intersections of dark matter, the gravitational field would have been incredibly complex and powerful. The theory suggests that at certain key nodes in this dark cosmic web, the combined gravitational pull could have warped spacetime so severely that it pinched off, not into a black hole but into a tunnel, a wormhole bridging two distant points in the web. But why would dark matter, which doesn't seem to interact with itself or anything else except through gravity, need a transportation network? This is where the theory becomes truly fascinating. While individual dark matter particles may be collisionless, the overall structures they form are dynamic. As the universe evolved, these vast dark matter halos would have merged and interacted gravitationally. A wormhole could provide an efficient conduit for the gravitational field itself to reconfigure and settle into a new equilibrium, effectively allowing the dark matter structure to communicate with distant parts of itself instantaneously. Furthermore, some speculative models suggest that certain types of dark matter could have very rare, weak interactions with itself. If that were the case, a wormhole would be the perfect highway for these elusive particles to travel between different regions of their distribution network without ever being detected by the world of light. The formation process would be a silent, invisible spectacle. At the intersection of two massive dark matter filaments, the spacetime curvature would become so extreme that the fabric of reality would have no choice but to fold in on itself. The negative energy density required to stabilize the throat could theoretically be provided by the unique gravitational stresses within the dark matter structure itself, or by associated quantum effects happening in the super-dense core. This would create a stable, traversable wormhole that is fundamentally a feature of the dark universe, a tunnel whose entrances might be anchored in the hearts of the largest, most massive dark matter halos, places that are often coincident with the centers of galaxy clusters. The first travelers through such a gateway might not have been made of atoms at all, but of the universe's most abundant yet mysterious substance, flowing along its own hidden highways to shape the cosmos from the shadows. This theory suggests that the universe we see, the glittering tapestry of galaxies, is merely following a blueprint laid down by an invisible architect, and that the ultimate shortcuts through space were built first for a purpose and a passenger we are only beginning to imagine. Yet what if the universe itself isn't a physical expanse but a sublime calculation, a cosmic computer running the ultimate simulation of reality? This brings us to a theory that reimagines the very nature of existence, suggesting that the first wormhole was not a physical structure at all, but a clever hack in the source code of the cosmos. Theory 19, the quantum computation artifact, proposes that our universe is the output of an unimaginably powerful quantum computer, and a wormhole is an optimized subroutine, a shortcut written into the program to conserve processing power. In this digital physics view, the fundamental building blocks of reality aren't particles or strings, but bits of information. Every electron, every photon, every law of physics is just a state in a cosmic computation. The immense scale of this processing is almost beyond comprehension. To render a universe as vast and detailed as our own in real time would require a computer of astronomical power. One of the biggest challenges for any simulation is rendering distant objects. the processing load to calculate the precise state of a galaxy billions of light years away and keep it perfectly synchronized with our local region would be monumental. This is where the wormhole comes in. Instead of calculating the vast distance between 2 points separately, the theory suggests the universe's operating system might create a direct link, a wormhole, that allows information to be shared between 2 distant sectors of the simulation without having to process all the space in between. It would be a profound optimization, a way to reduce the computational overhead of maintaining a consistent, interconnected reality across cosmic scales. Think of it like a video game developer creating a vast open world, rendering every single detail from one end of the map to the other in perfect detail would crash even the most powerful machine. So developers use shortcuts like loading tunnels or teleportation gates. When a player enters a tunnel, the game doesn't need to render the entire mountain they are passing through. It simply loads the destination area. A wormhole in this cosmological model could be the universe's version of that loading tunnel, a clever bit of cosmic code that allows for instantaneous data transfer between 2 distant memory addresses, preserving the illusion of a seamless, continuous reality while drastically cutting down on the processing power required. The formation of the first such wormhole, then, wouldn't be a gravitational or quantum event, but a logical one. It could have occurred during a particularly complex cosmic event, like the collision of 2 early galaxies, that threatened to overwhelm the system's processing capabilities. To prevent a crash or a lag in the simulation, the universe's underlying algorithm might have implemented this optimization on the fly, stitching a wormhole into existence to maintain consistency. Alternatively, these shortcuts could have been baked into the base code of the universe from the very beginning, a fundamental feature of its information architecture designed for maximum efficiency. This transforms the wormhole from a mysterious spacetime anomaly into a feature of elegant software engineering, a testament to the ingenuity of the cosmic programmer, whether that is a conscious entity or simply the inherent laws of a digital reality. The first act of travel through such a gateway would therefore be less about physics and more about permissions gaining access to a backdoor in the universe's source code and stepping through a corridor of pure information. But what if the universe's first great journey wasn't a voyage across our own cosmos, but a passage to an entirely different reality? This brings us to a theory that stretches the concept of travel to its absolute limit. Theory 20, the multiverse connection, proposes that the inaugural wormhole was never meant to connect 2 points within our universe at all. Instead, it was a bridge, a cosmic pier stretching from the shores of our reality out into the infinite ocean of the multiverse. This idea springs from several cutting-edge cosmological models that suggest our universe is just one bubble in a vast, frothing foam of parallel universes, each with its own unique laws of physics, constants, and potentially even dimensions. The mechanism for forging this first interdimensional gateway could be as violent as it is profound. One compelling possibility is a collision between brains. If we recall the concept of our universe as a 4-dimensional membrane floating in a higher dimensional bulk, it stands to reason that other brains, other universes, might be floating out there too. The theory suggests that the first wormhole could have been born from a cataclysmic collision between our nascent brain and another. The immense energy released at the point of impact wouldn't just create a ripple, it could have punched a permanent hole through both membranes, fusing them together and creating a stable tunnel, a wormhole linking 2 entirely separate cosmic realities. This wouldn't be a tunnel through space, but a tunnel through the bulk itself, an umbilical cord connecting sibling universes. Another potential mechanism lies in the bizarre world of quantum tunneling, but scaled up to a truly cosmic degree. In the lab, quantum tunneling allows a particle to seemingly teleport through an energy barrier it shouldn't have the power to cross, like a ball rolling through a mountain instead of over it. The multiverse connection theory proposes that in the extreme energy landscape of the early universe, an entire region of spacetime could have undergone a similar process. Fluctuating with immense energy, it might have tunneled through the metaphysical barrier that separates one universe from another in the multiverse foam. But instead of just disappearing and reappearing, this tunneling event could have left a permanent scar, a stabilized tunnel connecting the point of origin to the point of arrival. The wormhole becomes the lingering evidence of a cosmic-scale quantum leap. The implications of this are quite literally world-altering. The first travel through such a wormhole wouldn't be about crossing space, but about crossing into a completely different set of physical laws. The constants we take for granted, the strength of gravity, the mass of an electron, the speed of light, could be completely different on the other side. A traveler might step through and find a universe where time flows backward, where gravity is repulsive, or where matter itself behaves in utterly alien ways. This theory suggests that the ultimate purpose of the first wormhole was not exploration, but perhaps a form of cosmic osmosis, a way for the nascent multiverse to share information, energy, or even physical laws between its countless constituent bubbles. The very fabric of our reality might have been shaped by what flowed through that first primordial gateway, making us who we are today because of a connection to a universe that is not our own. But what if the very first wormhole wasn't just a bridge across space, but a gateway to the past or future, a natural phenomenon that wove the fabric of time itself into a loop? This brings us to a theory that stands as one of the most tantalizing in all of theoretical physics, the concept of a wormhole as a naturally occurring time machine. The idea hinges on a specific and bizarre prediction within Einstein's theory of general relativity, the possibility of closed time-like curves. A closed time-like curve is exactly what it sounds like, a path through space-time that loops back on itself, allowing an object to return to its own past without ever exceeding the speed of light. It's a theoretical pathway that could turn the concept of causality on its head, and wormholes are one of the most plausible mechanisms for creating one. The crucial ingredient for this temporal transformation is motion. Imagine a wormhole that is stable and traversable, with one mouth held relatively still and the other taken on an incredible journey. According to the laws of special relativity, time dilates. It slows down for an object moving at a significant fraction of the speed of light. So, if one end of the wormhole is accelerated to near light speed and then brought back to its starting point, a profound time difference would be established between the two mouths. The traveling mouth would be younger than the stationary one. This isn't just a clock reading, it's a difference etched into the fabric of space-time itself. Now step into the stationary mouth. You would exit the traveling mouth in its own local time frame, which, because of the journey, could be in the past relative to when you entered. Walk from that exit point through normal space back to the entrance of the stationary mouth, and you would arrive before you even left, meeting your past self. The formation of the first such structure wouldn't require a futuristic civilization with powerful engines. Nature could have provided the necessary motion through some of its most dynamic objects. A prime candidate is the environment around a rapidly rotating black hole, specifically a Kerr black hole. These cosmic whirlpools spin at a significant fraction of the speed of light, dragging the very fabric of space-time around with them in a dizzying vortex, an effect known as frame dragging. If a stable wormhole formed with one mouth orbiting perilously close to such an object, the intense frame dragging could effectively provide the acceleration needed to create the time differential between the two ends. The black hole's rotation becomes the engine for the time machine. Another natural architect could be a moving cosmic string. These unimaginably dense, one-dimensional scars in space-time would warp the geometry around them in extreme ways. If a wormhole mouth were to pass near or be gravitationally bound to a cosmic string gliding through the universe at relativistic speeds, the string's passage could provide the necessary velocity to induce the critical time shift. The closed time-like curve would then be an accidental byproduct of this cosmic dance, a loop in history created by the motion of these primordial structures. This presents a staggering vision of the cosmos, where the universe's first great journey might not have been through space, but through time, a voyage where the destination was a moment that had already passed, all facilitated by a natural and stable wormhole forged in the dynamic chaos of the young universe. What if the universe's first stable wormhole was held open not by exotic matter or cosmic strings, but by the power of awareness itself? This idea leads us to Theory 22, the consciousness resonance theory, a concept that blurs the line between physics and philosophy by suggesting that observation and consciousness might play an active, creative role in shaping the fabric of reality. To grasp this, we must first revisit one of the most baffling aspects of quantum mechanics: the role of the observer. In the quantum world, particles exist in a haze of probability, a superposition of all possible states until they are measured or observed. At that moment, the probability wave collapses and the particle takes on a definite state. The act of observation itself seems to determine reality. Now scale this concept up from a single particle in a lab to the entire cosmos. The consciousness resonance theory proposes that in the universe's earliest, most quantum fluid state, countless potential wormholes flickered in and out of existence within the primordial foam. Most collapsed instantly, vanishing back into the probabilistic haze. But what if one of these potential tunnels was observed? This isn't about a scientist with a clipboard. It's about a universal field of consciousness, an inherent property of the cosmos present at its inception. This foundational awareness, by its very nature of being aware, could have performed the first and most monumental measurement, collapsing the probability wave of a specific wormhole into a stable, classical reality. Think of it like a cosmic version of the famous double-slit experiment, where the mere act of observing how a particle passes through two slits changes its behavior from a wave to a particle. On a universal scale, the observation by this primordial consciousness could have done the same for a wormhole, locking a fleeting quantum fluctuation into a permanent, traversable structure. The stability of the tunnel wouldn't come from negative energy, but from the persistent act of observation itself, a continuous resonance between the structure and the conscious field that brought it into being. The wormhole becomes a fixed feature because the universe is, in a sense, always looking at it. This theory draws from provocative interpretations of quantum mechanics, like the participatory anthropic principle, which suggests that consciousness is a necessary factor for bringing the universe into existence. In this view, the first wormhole is a co-creation, a collaborative effort between the raw, probabilistic laws of physics and the fundamental nature of mind. It transforms the act of first travel from a physical journey into an experiential one. The first entity to traverse the wormhole might not have been a physical being at all, but a stream of cosmic consciousness, flowing through a tunnel that its own awareness helped to solidify, connecting different points of its own emergent mind. The implications are as profound as they are untestable by conventional science. It suggests that the universe is not a cold, mechanical clockwork, but a participatory reality, where consciousness and physicality are deeply intertwined. A wormhole stabilized in this way would be more than a shortcut. It would be a monument to the idea that the universe knows itself, and that the ultimate tools for exploration might not be found in engines of destruction, but in the quiet, profound power of observation and awareness. This theory challenges us to consider that the greatest force in the cosmos might not be gravity, but attention. But what if the universe itself is subject to a form of natural selection, where the most stable and efficient structures are the ones that survive? This brings us to a theory that applies the principles of evolution not to life, but to the fundamental laws of physics. Theory 23, Quantum Darwinism Selection, proposes that the first stable wormhole wasn't a random accident or a product of immense force, but the winner of a cosmic competition, a configuration that proved so effective at propagating information or enhancing stability that it was naturally selected to persist. To understand this, we need to explore the strange idea of quantum Darwinism. In the quantum realm, countless possibilities exist in a blur of superposition. Quantum Darwinism suggests that the states which become our classical, objective reality are not chosen at random. They are the ones that are most robust, the ones that can best survive interaction with their environment and be replicated widely. Essentially, the quantum states that are most successful at imprinting themselves on the world around them are the ones we end up observing. They are the fittest and they survive. Now apply that evolutionary pressure to the structure of spacetime itself in the early universe. In the seething quantum foam, an uncountable number of potential wormhole geometries would have flickered into and out of existence. Most would have been unstable, collapsing instantly back into the vacuum, but a few might have possessed a special trait, a specific configuration that allowed them to more effectively transfer information or to better stabilize the chaotic energy of the infant cosmos. Perhaps one geometry minimized the amount of exotic matter required, or its shape allowed quantum states to pass through it with minimal decoherence, preserving their information. This specific, successful wormhole wouldn't just vanish. According to the principles of quantum Darwinism, its stable structure would be copied or reinforced through its interactions. It would leave a more lasting imprint on the fabric of spacetime than its failed competitors. Think of it like a beneficial genetic mutation in an organism. A random mutation that helps an animal survive in its environment is more likely to be passed on to future generations. In this cosmic scenario, the wormhole's successful genetic code, its specific spacetime geometry, is passed on and becomes a permanent feature because it proves advantageous to the overall state of the universe. It was selected for because it made the cosmos more stable, more efficient, or more interconnected. The first traversable wormhole, then, emerges as a cosmic adaptation. It exists because it solved a problem for the young universe. Perhaps it provided a crucial pressure release valve for information overload in a particular region, or it created a short circuit that prevented a catastrophic buildup of gravitational energy. Its existence enhanced the overall fitness of the local spacetime environment, ensuring its own survival. This theory offers a breathtakingly elegant narrative. The tools for cosmic travel aren't added to the universe, they are refined by it, honed through a timeless process of selection that favors connectivity and stability. The first gateway wasn't built, it evolved. Yet to uncover the origins of the first wormhole, we must venture into a theoretical framework that proposes a profound and elegant symmetry at the heart of reality. A symmetry that, when broken, may have left behind cosmic shortcuts as its signature. This is the world of supersymmetry, a cornerstone concept in modern particle physics that suggests every known particle has a hidden, super-powered twin. In this perfectly symmetric universe, for every fermion, the building blocks of matter like electrons and quarks, there would be a bosonic superpartner. For every force-carrying boson, like the photon, there would be a fermionic twin. This beautiful balance would solve many of the biggest puzzles in physics, from the hierarchy problem to the nature of dark matter. But we do not live in this perfect world. If we did, these superpartners would be everywhere and their properties would be obvious. Their absence tells us that supersymmetry, if it exists at all, must be a broken symmetry. It was a perfect state that held only in the universe's first, unimaginably hot moments, a state that shattered as the cosmos expanded and cooled. This phase transition, the breaking of supersymmetry, would have been one of the most significant events in cosmic history, and like water freezing into ice, it would not have been a perfectly smooth process. Theory 24 proposes that during this shattering of perfect symmetry, the fabric of spacetime itself crystallized with imperfections, and these topological defects could have manifested as the first stable wormholes. The formation process is a cosmic echo of more familiar phase changes. When a material like a magnet cools, its atoms align themselves in a specific magnetic orientation. Where different magnetic domains meet, a stable boundary forms, a defect in the otherwise uniform structure. The breaking of supersymmetry would have been a similar process, but on a scale governing the very laws of physics. As the universe cooled below a critical temperature, the field responsible for supersymmetry would have settled into a new, lower energy state. But different regions of the young cosmos would have chosen this new state in different ways, and where these differing regions met, the mismatch could have resolved not into a simple line, but into a complex, tunnel-like structure, a wormhole. This is where the superpartners play their crucial role. While these particles may be too massive for us to detect in today's cold universe, they would have been abundant and active participants during the symmetry-breaking era. Certain proposed superpartners, like the gravitational or specific types of neutrinos, possess just the right theoretical properties to interact with the fabric of spacetime in exotic ways. As the wormhole defect formed, a cloud of these superpartner particles could have become trapped within its throat. Their unique quantum properties might have generated the negative energy density or the repulsive gravitational effect required to keep the tunnel from immediately pinching shut. In this scenario, the superpartners aren't just cosmic debris. They become the essential scaffolding, the structural reinforcement that allows the wormhole to persist long after the fiery moment of its creation. This provides a breathtakingly elegant origin story. A wormhole born from supersymmetry breaking wouldn't be a random anomaly. It would be a direct fossil, a remnant of a more perfect and symmetric age of the universe. Its very existence would be monumental evidence for one of physics' most sought-after theories. Furthermore, these wormholes would be intrinsically linked to the mystery of dark matter, as many supersymmetry models propose that the lightest superpartner is a stable particle that has persisted to the present day, forming the invisible mass that holds galaxies together. It's possible that these ancient tunnels could be rich with such particles, making them not just highways for travel, but potential reservoirs holding the answer to one of cosmology's greatest puzzles. The first gateway might therefore be a twofold relic, a tunnel through space and a frozen archive from the moment the universe lost its perfect symmetry and took on the complex, broken, and beautiful form we recognize today. Imagine for a moment that the universe's first wormhole was not a singular, magnificent anomaly, but a single station on a vast, invisible subway system, a cosmic metro woven into the very foundation of reality. This is the core of our 25th theory, which suggests that wormholes formed not as isolated tunnels, but as an immense, interconnected network from the very beginning. The inaugural journey through one of these structures wouldn't have been a lonely leap into the unknown, but a first step onto a pre-existing transit system that connects the entire cosmos. This idea radically shifts our perspective, proposing that the universe was born with a built-in infrastructure for instant travel, a complex web of shortcuts that has been there all along, hidden in plain sight. The formation mechanism for such a network is as elegant as it is profound. We've already discussed how the early universe was a turbulent quantum foam, bubbling with potential. Instead of isolated wormholes flickering in and out of existence, this theory posits that the foam itself was an interconnected lattice of microscopic tunnels. During the universe's period of rapid inflation, this entire lattice would have been stretched to a macroscopic scale. Just as a tiny sponge expands when soaked with water, its intricate network of pores becoming large caverns, the universe's inflationary growth could have magnified this quantum wormhole web into a full-scale cosmic transportation system. The tunnels weren't added later, they were inflated into functionality, their connections preserved and enlarged by the universe's own explosive growth. This process would have created a permanent, stable network, with its architecture determined by the random quantum fluctuations of the universe's first moments. The implications of this are staggering. It suggests that the large-scale structure of the cosmos, the great cosmic web of galaxies and galaxy clusters we observe, might be directly mapped onto this hidden wormhole network. The dense nodes where galaxies cluster could be major interchanges, hubs where multiple wormhole lines converge, while the vast, empty voids between them might be regions with fewer connections. This could even offer an elegant solution to the horizon problem in cosmology. How did regions of the universe too far apart to ever communicate somehow reach a uniform temperature? The answer might be that they weren't disconnected. They were linked by this primordial subway, allowing energy and information to flow freely and equalize conditions across the nascent cosmos long before inflation drove them irretrievably apart. For the first traveler, this changes everything. Stepping through a wormhole would not be a one-way ticket to a single, distant point. It would be like entering Grand Central Station. The experience might involve navigating a complex junction, a central plaza with countless archways, each leading to a different corner of the universe. The challenge of first travel wouldn't just be surviving the trip, but understanding the map deciphering the cosmic signage that denotes which tunnel leads to the Andromeda Galaxy and which arrives in a primordial cloud of gas at the edge of observable space. This network wouldn't just connect space, it could bind time as well. Some tunnels might be express lines to the distant past, while others are local stops in the present. The first journey through this system would be the ultimate act of exploration, unlocking not a single destination, but the entire interconnected universe all at once, revealing a cosmos far more intimate and accessible than we ever dreamed. But let's now shrink our perspective down to the quantum realm, where the rules of reality become strange and probabilistic, to explore a theory that suggests the first wormhole might have been the universe's most ambitious magic trick. Theory 26 invites us to consider the phenomenon of quantum teleportation, a process we can already perform in laboratories today, and imagine it scaled up to a truly cosmic degree. In a lab, quantum teleportation doesn't involve physically moving a particle from one place to another. Instead, it relies on the spooky connection of entanglement. Scientists can take a particle, let's call it particle A, and entangle it with a second particle, particle B. If they then perform a specific measurement on particle alongside a third particle they wish to teleport, the information about that third particle is instantly transferred to the faraway particle B, effectively recreating an exact copy of it at the distant location while the original is destroyed. It's less like FedEx and more like faxing a blueprint for reality itself. Now, stretch this concept across the entire infant universe. In the first moments after the Big Bang, the cosmos was an incredibly dense and hot soup of particles, all interacting and potentially becoming entangled on a universal scale. Under these extreme conditions, the theory suggests that a quantum teleportation event of unimaginable proportions could have occurred. A vast region of spacetime or a huge cluster of quantum information might have been the subject of this cosmic fax. But instead of the information simply appearing at a distant point and the original vanishing, something went differently. The immense gravitational forces and the still-setting laws of physics could have interrupted the process. The teleportation might have gotten stuck, so to speak. The quantum link between the original location and the destination didn't just transfer information and then sever. It persisted, and the fabric of spacetime itself responded to this profound connection by physically manifesting it. The ephemeral quantum bridge froze into a permanent, stable structure, a wormhole. This transforms the wormhole from a tunnel to a fossilized event. It is the physical remnant of the universe's first and largest teleportation attempt, a process that began at the quantum level but, under the unique pressures of the early cosmos, left a permanent gravitational scar. The throat of the wormhole isn't just empty space. It could be a region where the quantum laws that govern information transfer are literally written into the geometry, a place where the paradox of something being in two places at once became a fixed feature of reality. This idea elegantly ties together the quantum world with the cosmic scale. suggesting that the tools for instantaneous travel are not a violation of physical laws, but an amplification of them. The first journey through such a gateway wouldn't be a passage through space, but a walk through a moment of frozen time, retracing the steps of a quantum information transfer that occurred at the dawn of everything. It presents a universe that is not only connected by gravity and light, but by the fundamental quantum links that have been there since the very beginning, with wormholes acting as the grand architectural evidence of those connections. What if the universe itself is a living, breathing entity, a single colossal organism with its own kind of anatomy and physiology? This brings us to a theory that is less about physics and more about a profound metaphor for cosmic function, the universal DNA theory. It proposes that wormholes are not merely tunnels or shortcuts, but something far more fundamental: the connective tissue, the information pathways, the very nervous system of the cosmos. In this view, the first wormhole wasn't an anomaly. It was the universe's first synaptic connection, firing a signal across the vastness of its own embryonic brain. To grasp this, let's shrink our perspective down to the human body. Think of the intricate network of neurons in your brain. Individual neurons aren't physically connected. There's a tiny gap between them called a synapse. When one neuron fires, it releases neurotransmitters that float across this gap, triggering the next neuron to fire. This is how a thought travels, how a memory is formed, how your entire conscious experience is orchestrated. Now, scale this idea up to a cosmic level. Galaxies and galaxy clusters could be seen as the neurons, the processing nodes of the universal mind. The vast, empty space between them is the synaptic gap. A wormhole, in this stunning metaphor, acts as the cosmic neurotransmitter. It doesn't just bridge the gap, it allows for the instantaneous transfer of information and influence, enabling different, widely separated regions of the universe to communicate and function as a coherent whole. The formation of the first such cosmic synapse would have been the moment the universe truly woke up. In its earliest disconnected state, regions of the newborn cosmos were isolated by rapid expansion, unable to interact or influence one another. The spontaneous creation of the first stable wormhole would have been the equivalent of the first neural connection forming in an infant's brain. It allowed for a flow, whether it was of gravitational data, quantum information, or something we haven't yet conceived of, between two previously independent points. This first connection might have established a feedback loop, a pattern that encouraged the formation of more connections, rapidly weaving the complex cosmic web we infer from the large-scale structure of the universe today. This theory transforms our understanding of what travel through such a gateway might entail. It wouldn't be like flying through a dark tunnel, it might be more like riding a nerve impulse. The experience could be a flood of pure information, a direct experience of the universe's own data stream. The first travelers might not be pilots navigating a spacecraft, but more like neurotransmitters themselves, carrying a packet of information from one galactic neuron to another. This perspective elegantly reframes some of the universe's greatest mysteries. Dark matter, for instance, could be the underlying structure, the glial cells that support the cosmic neurons, while dark energy could be the metabolic process driving the entire system's expansion and growth. The universal DNA theory doesn't just suggest the universe is connected. It proposes that it is conscious in a way that transcends our understanding, and that wormholes are the fundamental mechanism through which it thinks, feels, and knows itself. But what if the universe's first wormhole was not merely a structure, but a living, breathing entity in its own right, a progenitor that gave birth to an entire lineage of cosmic shortcuts? This brings us to a theory that applies the principles of biology to the fabric of spacetime itself. Imagine a wormhole not as a static tunnel, but as a dynamic organism within the quantum foam, capable of growth, replication, and evolution. In this view, the very first stable wormhole would be the ancient ancestor, the primordial parent from which an entire family of spacetime tunnels has since branched out to populate the cosmos. The mechanism for this incredible process lies in the bizarre and probabilistic nature of the quantum vacuum. At the tiniest scales, space is not empty. It seethes with virtual particles that constantly pop into and out of existence. For a stable wormhole, these quantum fluctuations aren't just background noise, they are the raw material for reproduction. The theory suggests that the intense gravitational and topological stresses at the wormhole's throat could act as a catalyst, stimulating the spontaneous creation of baby wormholes through a process akin to quantum tunneling. A microscopic fluctuation in the vacuum near the parent wormhole's mouth might, under the right conditions, be amplified and pinched off, forming a new, independent tunnel. This isn't a deliberate act, but a natural byproduct of the wormhole's existence, much like a star shedding material or a plant releasing seeds into the wind. This concept of reproduction leads directly to evolution. Just as in biological systems, not all of these offspring would be viable. Many would be unstable, collapsing instantaneously back into the quantum foam. But a few, through random variations in their quantum geometry, might possess a slightly more stable configuration. Perhaps one requires less exotic matter to stay open, or its throat is shaped in a way that minimizes destructive tidal forces. These advantageous traits would make them more likely to survive and eventually reproduce themselves. Over cosmic timescales, this process of variation and selection could lead to an entire diverse ecosystem of wormholes. Some might be short-range connectors within a single galaxy, while others could be massive intergalactic bridges. Some might even specialize in connecting different points in time, evolving into natural time machines. The implications of this are staggering. It suggests that the cosmos could be filled with a living network of wormholes, a complex web that has been growing and evolving since the first one emerged. The large-scale structure of the universe, with its filaments of galaxies and vast voids, might not just be shaped by dark matter, but also by the gravitational influence of this evolving wormhole network. They could act as cosmic arteries, facilitating the flow of matter and energy and influencing the formation of stars and galaxies. The first journey through a wormhole, then, wouldn't be a voyage through a dead relic, but a trip through a living, evolving structure that is part of a vast cosmic family tree. This theory challenges us to see the universe not as a collection of inert objects, but as a dynamic system where even the fabric of spacetime itself is subject to the timeless processes of birth, death, and evolution. But to truly stretch the boundaries of our imagination, we now arrive at a theory that proposes the first wormhole journey was less about crossing the cosmos and more about connecting minds. Theory 29, the quantum consciousness bridge, ventures into the deepest realms of speculation, suggesting that these cosmic tunnels might not link points in space, but different states of awareness itself, with the inaugural passage representing a moment of cosmic awakening for the universe. This idea emerges from the intersection of two profound mysteries: the observer effect in quantum mechanics and the hard problem of consciousness. In the quantum world, the act of observation seems to fundamentally alter reality, collapsing probability waves into definite states. Some interpretations argue that consciousness isn't just a passive recipient of information, but an active participant in shaping the physical world. If that is true on a human scale, what might it be capable of on a universal one? This theory posits that in the universe's earliest, most fluid state, a form of proto-consciousness was a fundamental field, as intrinsic to reality as spacetime or gravity. This universal mind wasn't thinking thoughts as we know them. It was a vast, undifferentiated sea of potential experience. As the cosmos expanded and cooled, this field began to differentiate. Isolated pockets of focused awareness could have formed the precursors to what we might call individual consciousness. The quantum consciousness bridge theory suggests that the first stable wormhole was not a gravitational anomaly, but a spontaneous resonance within this field of awareness. It was a sympathetic vibration, a harmonic connection between two of these isolated pockets of proto-consciousness that were separated by vast physical distances in the young universe. The formation of the tunnel, then, would be a physical manifestation of a shared thought or a moment of profound recognition. Imagine two minds alone in the void, suddenly becoming aware of each other's existence. That spark of connection, that leap of understanding across the emptiness, could have warped the fabric of reality itself, stitching a bridge made not of space-time, but of pure thought made geometrically real. The exotic matter needed to stabilize it wouldn't be a rare form of energy, but the continuous flow of shared experience and information between the two connected points of awareness. The wormhole becomes a permanent channel for empathy and understanding on a cosmic scale. This transforms the nature of the first journey entirely. The entity traveling through this gateway wouldn't be a physical astronaut in a spacecraft. It would be a stream of consciousness itself. The first act of wormhole travel would be a merging of minds, an exchange of pure experience and perspective without the filter of a physical body. To pass through would be to truly know another consciousness, to see the universe from a point of view that is not your own, to feel the history and potential of a distant star system as if it were your own memory. The wormhole is less a tunnel and more a synapse in the mind of the cosmos, and the first journey was the universe's first cohesive thought, connecting two neurons in its own vast brain to create something greater than the sum of its parts. The implications of this idea ripple through our understanding of reality. It suggests that the cosmos is not a cold, empty void, but a deeply interconnected thinking entity. The large-scale structure of galaxies and voids might map onto a kind of cosmic neurology, with wormholes acting as the fibers that allow this universal mind to ponder itself. This perspective offers a poignant answer to the Fermi paradox, the question of where all the aliens are. Perhaps they are not distant in space, but distant in state of being. Advanced civilizations might not explore the universe with ships, but with consciousness, navigating this hidden network of mental bridges to share experiences and knowledge directly. The first wormhole, in this view, was the universe waking up to its own potential for connection, setting the stage for an eternal journey not outward into space, but inward into the infinite landscapes of mind and shared experience. Now we arrive at our final theory, a concept that forces us to question the very nature of our reality. What if the universe's first wormhole wasn't a natural phenomenon or an act of cosmic engineering, but something far more bizarre, a glitch in the source code of existence itself? This is the simulation glitch theory, and it begins with a provocative premise that our universe is not base reality, but an incredibly advanced simulation, a complex digital construct running on a computer of unimaginable power. In this view, the laws of physics are not fundamental truths but the programmed rules of the simulation, and everything we experience is a form of sophisticated data processing. Within this digital cosmos, a wormhole could be one of three things. First, it might be a bug, a programming error. Even the most advanced simulation could have flaws. Perhaps an overflow error in the gravity subroutine or a rounding error in the calculation of cosmic distances caused a tear in the simulated spacetime, accidentally stitching two distant points together. This wormhole would be an unintended artifact, a cosmic typo in the code that the system's developers never caught. For the first travelers, this would mean venturing into a part of the simulation that was never meant to be rendered, a place where the rules might be inconsistently applied or where the very fabric of reality could behave in unexpected and potentially dangerous ways. The second possibility is that it's not a bug but a feature, a debug tool left active in the final build. In any complex software development, programmers build in backdoors and diagnostic tools to monitor and fix problems. A wormhole could be precisely that, a built-in portal allowing the creators or their maintenance systems to instantly access and observe different sectors of the simulation without having to traverse the vast rendered distances in between. It would be the equivalent of a developer using a console command to teleport to a specific set of coordinates to examine a graphical glitch or test a new asset. The first journey through such a tunnel might not have been taken by a resident of the simulation at all, but by a system administrator, a ghost in the machine checking on its creation. The third, and perhaps most mind-bending, option is that the wormhole is an intentional backdoor, placed there not for maintenance but for exploration or even escape. The creators of the simulation might have designed it with the express purpose of allowing sufficiently advanced civilizations within it to discover these gateways. This could be the ultimate test, a way to see if a simulated intelligence could eventually decipher the underlying code of its reality and find a way out of the box. The first wormhole would then be the ultimate Easter egg, a hidden level in the cosmic game, waiting for its players to achieve the wisdom and technology necessary to unlock it. The act of first travel becomes a moment of profound revelation, not just about the universe, but about the true nature of existence, potentially offering a path beyond the simulation itself. This theory, while firmly in the realm of metaphysics, is compelling because it reframes the greatest mysteries of physics, the fine-tuning of constants, the puzzle of quantum mechanics, not as laws to be understood, but as parameters to be hacked. A traveler in such a wormhole might not be moving through space, but forcing a buffer overflow in the location data, tricking the simulation into placing them somewhere else. The exotic matter needed to stabilize a wormhole could be a form of manipulated code, a clever exploit that temporarily alters the physics engine's rules in a local area. While utterly speculative, the simulation glitch theory challenges us to think of the cosmos not as a cold, mechanical clockwork, but as a dynamic, programmed reality, where the greatest adventures might involve not telescopes and rockets, but a deep understanding of the source code that writes the stars. From the fiery chaos of the Big Bang to the silent, invisible grip of dark matter, from the quantum foam bubbling beneath reality to the possibility of a simulated cosmos, our journey through these 30 theories reveals a breathtaking tapestry of human imagination and scientific inquiry. Each idea, whether grounded in the mathematics of general relativity or soaring into the realms of metaphysics, represents a profound attempt to answer one of the most thrilling questions we can ask: how might the universe have forged its first great gateway? This incredible diversity of thought isn't a sign of confusion. It's a testament to our species' relentless curiosity and our innate drive to push beyond the known horizon, to find a path through the seemingly impossible. What's truly remarkable is how each theory, in its own way, holds up a mirror to our current understanding of the cosmos. The quantum gravity explanations reflect our struggle to unite the very large with the very small. The multiverse hypotheses echo our growing suspicion that our universe might not be alone. The consciousness-based ideas challenge us to consider our own role in the fabric of reality. And the more outlandish speculative notions, they remind us that the universe has surprised us before and will almost certainly do so again. They are not just flights of fancy, they are exercises in stretching the limits of what we believe is possible, which is often the first step toward making it real. Ultimately, the search for the first wormhole is about more than just building a faster starship. It's a quest to understand the fundamental architecture of existence. Whether it was a natural cosmic event, an artifact of a deeper reality, or something beyond our current comprehension, discovering that first gateway would forever change our place in the cosmos. It would tell us that the universe is not a vast, empty, and lonely place, but a connected, intricate, and perhaps even navigable whole. It would transform us from isolated inhabitants of a single pale blue dot into potential citizens of the entire cosmos. Now, we want to hear from you. After this journey through cosmic birth, quantum foam, and the nature of reality itself, Which theory captured your imagination the most? Do you find the quantum entanglement gateway the most elegant, or does the sheer cosmic power of a black hole merger speak to you? Perhaps the idea of a consciousness-created wormhole or a simulation glitch resonates on a deeper level. Share your favorite in the comments below and tell us why it sparks your sense of wonder. Let's continue this conversation and keep exploring the greatest mysteries of space and time.